students, in last lecture we studied about cantilever beam having point load at its free end. That is your case number 1, and we solve one example related to that case number 1. Next we studied about case number 2, which is cantilever beam, but it has UDL in its whole span, and we solve one example related to case 2 also. Today we will see the case number 3, in which cantilever beam which have point load at its end as well as it has UDL on its whole span. So in this case number 3 કે જેની અંદર બીમ છે કેન્ટિલીવર that is A B જેના છેડા ઉપર પોઈન્ટ લોડ લાગે છે તથા જેના આખી લંબાઈ ઉપર UDL પથરાયેલો છે. તો આ કેન્ટિલીવર બીમની અંદર જેમ આપણે પહેલો કેસ સોલ્વ કર્યો જેની અંદર કેન્ટિલીવર બીમના છેડા ઉપર પોઈન્ટ લોડ લાગતો હતો, જ્યારે બીજા કેસની અંદર કેન્ટિલીવર બીમના આખી લંબાઈ ઉપર યુનિફોર્મલી ડિસ્ટ્રીબ્યુટેડ લોડ એટલે સમવિતરિત ભાર પથરાયેલો હોય છે. તો તે હતો આપણો કેસ નંબર 2. આજે આપણે બીમ છે આપણું કેન્ટિલીવર, પણ એની ઉપર પોઈન્ટ લોડ છેડા પર લાગે છે તથા જેની ઉપર UDL પણ એના આખા સ્પાન ઉપર પથરાયેલો છે. તો આ કેસની અંદર આપણે જ્યારે પહેલો કેસની અંદર પોઈન્ટ લોડ લીધો જેને આપણે દર્શાવ્યું છે W1, અને બીજા કેસની અંદર UDL કે જેને આપણે દર્શાવીશું W2, that is in kilonewton per meter or newton per millimeter. હવે જેમ આપણે કેસ નંબર 1ની અંદર સ્લોપ શોધવા માટેનું સૂત્ર જોઈ ગયા તે મુજબ જ અહીંયા એ ફોર્મ્યુલાનું એડિશન જ થાય છે. એટલે થીટા બી એટલે કે સ્લોપ એટ પોઈન્ટ B when point load is exerted on a cantilever beam at its end. The formula is W1 L square upon 2EI. That is the formula of slope in which beam is cantilever and load exerted on it at its end is point load. So this one is our case number 1. That is added by case number 2, that is cantilever beam with UDL, that is W2 Newton per mm. So plus W2 L cube upon 6 EI. So this formula is of cantilever beam with point load at its end, plus this formula is cantilever beam with UDL on its whole span. Similarly, to find out deflection, વિચલન શોધવા માટે પણ સેમ ફોર્મ્યુલા યુઝ થશે. That is W1 L cube upon 3I, which is the formula of case number 1 to find out deflection, plus W2 L raised to 4 divided by 8EI. That is the formula of cantilever beam having UDL on its whole span. Today we will solve the example of this case number 3, which is cantilever beam which have point load at its end, that is W1, and W2 which is UDL on its whole span. So the example related to case number 3 is ત્રીજા નંબરના કેસનો અંદર એક્ઝામ્પલની અંદર તમને રકમ આપી છે કે એક 2.1 મીટર લાંબા કેન્ટિલીવર બીમ પર 60 કિલોન્યુટન પર મીટરનો સમવિતરિત ભાર લાગે છે. તો સમવિતરિત ભાર એટલે જેને આપણે દર્શાવીશું W2, that is 60 kilonewton per meter, which is converted into 60 Newton per mm. That is your unit conversion. kilo 10 raised to 3, 60 into 10 raised to 3 divided by meter, which is converted into millimeter, that is 1000. So 1000 and 1000 cancel out and you will get 60 Newton per millimeter. તેની સાથે એક 150 કિલો ન્યૂટનનો બિંદુ ભાર તેના મુક્ત છેડા ઉપર મૂકેલ છે. તો મુક્ત છેડા ઉપર જે લોડ મૂકેલ છે that is indicated by W1, which is equal to 115 kilonewton, that is converted into 150 into 10 raised to 3 Newton. Kilo says 10 raised to 3. So kilonewton is converted into Newton. So 150 kilonewton is converted into 150 into 10 raised to 3. Length is equal to 2.1 meter of cantilever beam. So it is converted into millimeter, that is 2100 millimeter. આ બીમ માટે 4 into 10 raised to 13 ન્યૂટન into millimeter square ની flexible rigidity લઈ મહત્તમ ઢાળ અને વિચલન શોધો. અહીં ફ્લેક્સિબલ રિજિડિટીની વ્યાખ્યા પણ મળી જશે. ફ્લેક્સિબલ રિજિડિટી ઇઝ ઇક્વલ ટુ કેપિટલ E ઇન્ટુ I. સો મોડ્યુલસ ઓફ ઇલાસ્ટિસિટી અને મોમેન્ટ ઓફ ઇનર્શિયાના ગુણાકારને ફ્લેક્સિબલ રિજિડિટી કહેવાય છે. ધેટ ઇઝ ઇક્વલ ટુ 4 into 10 raised to 13 Newton into millimeter square. First we will find out the slope and then we will go to find out deflection. So in this formula you have a cantilever beam in which point load at its free end and UDL on its whole span. Point load is indicated by W1 and UDL indicated by W2. That is the only difference between case number 3 and case number 1 and 2. So slope is equal to theta b, that is slope at point B is equal to W1L square divided by 2EI, that is the formula for cantilever beam having point load at its free hand, plus W2L cube upon 6EI, that is the formula for case number 2. Substitute the value which are given in the data, that is W1 is equal to 150 into 10 raised to 3, that is multiply with 2100 square, divide by 2 EI is given, that is 4 into 10 raised to 3, that is flexural rigidity, plus W2 is 60 into L is 2100 cube, divided by 6 into EI, that is flexural rigidity, 4 into 10 raised to 3. And answer by using scientific calculation, that will give you an answer which is 0.0105 radians. So slope is measured in radians. Next we will go to find out the deflection. So the formula for deflection is equal to YB is equal to W1 L cube upon 3EI plus W2 L raised to 4 divided by 8EI. Substitute the data in this equation. We will get 150 into 10 raised to 3. W1 L is equal to 2100 cube divided by 3 into flexural rigidity, plus W2 60 into 2100 raised to 4 divided by 8 into flexural rigidity, 4 into 10 raised to 13. And answer of this calculation will give you 15.21 millimeter. So we have seen the example related to case number 3, which is cantilever beam with point load at its end as well as UDL on its whole span. Next we will see the same 3 cases, but our beam is simply supported beam. In this simply supported beam, simply supported beam is two support beam having support at its two end and load is exerted on it as a point load at its midpoint. So case number 1 is simply supported beam with point load at its center. So the formula to find out slope and deflection are theta A or theta B, which are the slope at point A and point B. That is equal to WL square divided by 16 EI radians, and maximum deflection is equal to maximum deflection is created at point C, that is at the center of beam AB. So deflection YC is equal to WL cube upon 48 EI. 48 याद रखवा माटे you can use 16 multiplied by 3, that is equal to 48 EI, that is in millimeter. In next lecture we will see the example related to case number 1, which is simply supported beam with point load at its center.